Now we got everybody here. So we got 3 roomers, got our Zoomers, we're ready to rock and roll. So first up, I put up some new materials for today that I'm almost 100% certain we won't have time to get to, but I try to put things together that go together. So I put up example 5A and the files that go with it. This is going to be the first in a couple examples where we're going to do part 1 in one lecture, and then I'm saving the second half of it for path models. So I want to be able to show you how to fit the same types of multivariate models in a couple different ways so that you can understand the connections between them and understand when you could choose one versus the other versus when you have to do it a certain way. So the first part of that will be immediately relevant. The second half we'll eventually get to. The other thing I wanted to point out, as I got too excited about finishing homework and screwed up, so I sent out an email about this yesterday. So this is your homework that's due Monday. And initially, I had 2 questions in here about a walled test chi-square and a p-value that went with it. And I went through and did the whole homework and answered all the questions using Stata and R and realized that we were not going to get the same answers across the program, so I decided to eject. And as I described last time, reordering these things takes an ungodly amount of effort, so I just punted. So enter the number 1 if you're ready to answer some questions about interaction terms, was the question I decided to settle on. But then I forgot, down in the results section, to remove the references to that chi-square test, the walled test. So that's my bad. So I changed it so that it at least makes sense rather than what I had before. So there is a question about whether or not the slopes that contribute to the moderation, so the effect of full-time work, the effect of food school, and their interaction terms, whether or not that set of slopes significantly contributes to the model. So you should all be able to compute your walled test chi-squares and get to the correct answer because of the way I generated the data. It's going to be an obvious choice, even if your exact chi-square values do not agree. And so then you can also answer, so significant or non-significant with respect to that test statistic, even though it's not asked for in any of the earlier questions, as well as degrees of freedom. So a couple of you had already submitted your homework, and so I reset your homework if you had done that and sent you an email about it. That way you can get a chance to make sure that you're happy with your choices, given that I changed this. So are there any questions about homework or this typo that I had to correct? So homework 4 we're talking about.
So I have a question.
Yes.
I was really wrestling with R last night, trying to, well, so do you, for the questions that I asked for, what is the predicted log count given these values for these attributes?
Yes.
Do you use the prediction function for that in R?
You can.
Okay.
You can either write out GLHT statements for each one, or you can use the prediction function to ask it for predictions over a range of values. So these these questions that you're asking about are question 32 through 39. All of them have in common that they're specifying it for a child that doesn't have any siblings. So those would be held constant across your prediction equations. And it's varying with respect to full-time work status and number of food school sessions. So I believe you should be able to use either prediction or a GLHT statement to get each of those. If you use prediction, you would want to do type equals response so that you're in predicted count as opposed to log count.
Okay. And the other thing I was wondering too, so just when you have an interaction term, so, and for this week, it was the session or session amount versus the categorical attribute full-time work.
Mm-hmm.
If session amount increases by like 3 times, 5 times, does the interaction term also, does that slope value also increase by 3 or 5 times?
I'm not following the question. As what increases 3 times?
Like because in 28, for instance, 28, it says attended food for 3 sessions. So, so that like the session, like the if and how many part of the model, if we plug 3 in for that to, oh wait, I think I'm discovering where I went wrong.
Yeah, it's not 3,
Never
is
mind.
it? Yeah. So,
Never mind.
question 28, enter the difference in predicted log count, so we know that we're within the model scale, for children whose parents do not versus do work full-time. So this part of the question, that's asking for the slope of full-time work. That's the unit of request here. It is for moderator values of food school of 3 sessions. So that a 3 does not go in your code, because you would have to turn on any food school to go from a 0 to 1, and then the other variable is number of sessions past 1. So you would put a 2 there, not a 3.
Oh.
Yeah.
That's where I went wrong.
Yep. So all of my requests here are in the metric of the original variables for the predictors, and you have to figure out what their corresponding centered values would be to put into the prediction statements. Other questions? No, is this going okay so far? So far, so good? It gets a little bit easier each time, right? Just a little. Oh, Vladimir's laughing at me. Maybe not. Maybe not, but that's because I'm mean. I'm okay if everyone hates me right now, because eventually I hope that you're able to do this on your own, and then you'll hate me this much less. For the record, I hate myself right now too, so. I spent all day yesterday fighting with R and developing like a 30-page handout, and I thought, Lisa, you are insane. But in a good way. In a theta hat kind of way. So, there we go. I can teach like this. I can sleep like this. Hey. Yes.
And the question 23 and 24.
Yes. So question 23 and 24. Okay, so per food school a session attended is the slope that we're focusing on. So what is the effect of going to more food school sessions relative to fewer, if you've been to at least one? So the unit of analysis in this question is the slope for how many sessions you attended for food school. I called that amount in class on Tuesday. And so then it's asking, specific to the moderator variable of full-time work being 0 for question 23 and full-time work being 1 in question 24.
These 2 questions, I need to calculate. Yeah, we need to find out the difference of y hat.
I wouldn't go for it as y hat. I would go for it as what is the slope that describes the change in log count per additional food school session attended. That's what I'm asking for, is the slope. Yes, and then it's the slope for a particular kind of child whose parents don't work full-time as the moderator versus do. So some of these are going to be given directly as model parameters. Anything that is phrased to refer to a reference value of a predictor is going to be in the model somewhere, and anything that is not phrased as a reference value of a moderator is going to be a linear combination via GLHT in R or Lincom in Stata or estimate in SAS.
Just for the record, I had my R code pulled up. I put in a 2 and now it works. So I was literally going through and trying everything else besides that. So
Yeah.
right.
I'm not sure if that makes it better or worse to realize that the mistake is something that straightforward. But that's good though, right?
No, it's good. Good ending.
Yeah, if that's the only thing that went wrong, then that's like you got 99% of the way there. So that's a good thing. All right, Chen Chen, does that help clarify? Okay. Yeah, if you're reading through these and you don't know what I'm asking, please send me an email and I'll be happy to clarify. I try to always phrase it so that the thing I'm asking for is first, and then the moderator value for it is second, so that it has a common structure. But that doesn't necessarily always make sense to those of you who are reading it for the first time. So don't feel bad, Nathan.
One other quick question. When in the prediction function, what is it? This type equals response versus link. What does that mean again?
Link is going to be in model scale, so in log counts or logits or probits or whatever your model is in.
Oh, okay.
Yep. And the type equals response is inverse link. So probabilities, counts, etc., proportions, data scale, as we call it. All right, I just spent like 7 emails back and forth helping a student in my other class troubleshoot R code, and it turned out to be the difference of a capital letter S versus a lowercase letter s. Like an hour later, that's what we landed on was the problem. So it's just that kind of day where we can get 99% of the way there, but one little just thing. You would think that the software would be smart enough to be like, I knew what you meant, let me fix that for you. But no, software does not work that way. Okay, other homework questions. All right, just as a reminder, anyone is welcome to come and hang out during office hours. I have several students who do that. They just sit in the background and work on homework, and then they ask me questions if they have them, and they work in between. So if anyone wants to join the party and do that, you're certainly welcome to. Otherwise, shoot me emails. Let me know if you need help. Do Monday night. Okay. All right. Then let me see here. Yeah, I talked about that. We have quantile regression output to go through, and then we get to start multivariate models today. Hooray! Then we're on much more solid ground with respect to things that I understand better and have taught before. So we're moving away from the whole idea of Lisa learned this 10 minutes ago and she's trying to present it, which is always a dangerous feeling. For those of you who are learning how to teach or getting practice teaching, that's the worst, right? When you're not sure what you're explaining and it's like, wah! But after this, I feel like I'm on much more solid ground. So this is the last thing that we have to do in example 4B. So I am starting on page 15 of that, looking at examples using quantile regression. So just to remind you the background of these data, I borrowed these data from the Agresti 2015 book. These are sales of house prices, and we are predicting the sale of a house price from characteristics of the house in about 100 houses. So whether it's new construction, number of bedrooms, number of bathrooms, and a quadratic function of square footage centered so that the reference house is 1,500 square feet. So this was, let me show you the marginal distribution again. Actually, let me show you the residuals. So these are the residuals for home price if we fit just a standard general linear regression. So it looks like there's actually a little bit less variability than what a normal distribution would entail, but along with some outliers. So there's some houses that, for instance, were super cheap down here, even though they were predicted to be very expensive. So we still have the issue potentially of extreme observations pulling the regression lines that we might want to consider an alternative approach for. So that one possibility, besides all of the log normal residual models and the gamma residual models, is to do what's known as quantile regression. So the difference is that rather than predicting the conditional mean, we are predicting, to start with here, the conditional median. So what's the difference between a mean and a median? Let's back way up. Back to like 6th grade or something when you would have probably first heard these terms. What's the difference?
The mean is sensitive to outliers.
Yeah, the mean is sensitive to outliers. And why isn't the median sensitive to outliers?
Because it drops everything, with just about everything.
It drops everything?
Like just about everything other than the middle value.
Yeah, I mean, the median is literally the middle value. So if you arranged all of the houses in a row from most to least expensive, the median is the middle. And so it doesn't matter how much far away from the middle the extreme observations are, the middle is the middle. So the definition of median is that 50% of the houses are above it and 50% are below it. And that is one of the reasons why median home price is a thing as opposed to mean home price, is because home price distributions tend to be positively skewed, and super expensive houses can drag the mean to be higher than what would be a good estimate of central tendency. So quantile regression is an extension of the idea of substituting medians as estimates of central tendency, but it is flexible enough that you can predict any quantile, or percentile really. I'm not sure why it's called quantile. Really what they mean is percentile. So the difference is that rather than minimizing the sum of squared errors, we are trying to minimize the absolute value of the error, and that is not differentiable in the same way, so we have to rely on some kind of iterative procedure to get standard errors. I was unsuccessful at figuring out how to do this in R. So in the R output that I have, I just have point estimates and I think some kind of confidence interval, because there were many different options for how to get standard errors and none of them looked familiar to me, so I decided just to give up. But within at least SAS and Stata, I was able to do this fairly easily. So the options in SAS, proc quant reg, as usual, you tell it what data. Here is how I'm asking it to get standard errors and confidence intervals. I'm asking it to do bootstrap resampling with 500 replications. And because of that, I am adding a seed so that I can get the same results over and over again. In practice, you wouldn't necessarily always have the same seed, but I do this in my handout so that all of the numbers can agree to the greatest extent possible. And as discussed last time, Jenny is my seed. The 80s song, 8675309, is what it's called, for those of you who are going to go to the YouTube. I'm asking it for the 50th quantile, quantile equals 0.5 here. The model statement looks exactly the same as what we're used to otherwise. Outcome variable equals all my predictors. This thing is the analog to a contrast statement. It looks a little bit different, but it functions similarly. So I am creating a label that would normally be in pink quotes here. The command is called test, and then I'm listing all the things I want to lump together. So this would be the analog to the F test for the model R square, except that I'm asking it to do, I can't remember if I got F or chi-square out of this. We'll find out. There's a couple different variants of it that you can request. In Stata, the setting of the seed comes first, but then I have SQReg as the thing that I'm using to estimate the model. So outcome variable is price. Here are all of my predictors. I am asking it to give me the 0.5 quantile, and replications are 500. And I'm using a test statement to get my F test for the model, and it does not match SAS, and I do not know why. So it's doing something different behind the scenes that I am not privy to. I looked through the documentation and couldn't figure it out, but this is a normal test statement with respect to how we would typically ask for joint tests of slopes across multiple predictors at the same time. And in R, it is a package called QuantReg with just RQ. Tau, I figured out, is how you specify which quantile that you want. And then the formula specifies the model in the usual way. So any questions on the syntax? Looks fairly straightforward. So then the output that we get also looks fairly straightforward. And the only difference in how we would talk about it is rather than saying that, predicted income, we would refer to the predicted median. So for the reference house, the median price is predicted to be $133,000. That would be a house that is old construction with 3 bedrooms, 2 bathrooms, and 1,500 square feet. And we would talk about what happens to the predicted median as a function of each of these slopes. So if it's new construction, the median is predicted to be $1,000 higher in terms of the home price. And that is not significant. It looks like the only things that is significant in this analysis is square footage. And the direction of this is a little bit different than what it was in some of the previous models. This is a positive linear slope paired with a positive quadratic. So a little bit of review here. What kind of pattern do those two signs create? What happens to the slope of square footage as you get into larger houses?
It increases?
It increases. Yeah, this is an acceleration.
Okay, yeah.
And what's the rule about what you do to a quadratic coefficient to describe how it works in the model?
We have to duplicate the number?
Yeah, multiply it by 2. That's the trick. If you can remember that, you're home free. So the way that I would talk about this is that at 1,500 square feet specifically, for every additional 100 feet, the median price goes up $8,600, and that positive slope of 8.66 becomes more positive by 0.76-ish. So this number multiplied by 2. So the slope speeds up by twice the quadratic per unit x, which in this case is per 100 feet. Putting that into English would be something like, house size matters more the larger you get. The extent to which house size predicts price increases. The effect strengthens. So other than remembering that you're predicting the median, everything kind of works the same. The Stata results helpfully remind you what you're predicting. That's foreshadowing for some of the other options. And it labels the standard errors as bootstrap standard errors. And it agrees pretty much with respect to what we found here. Those are the two things that were significant. According to Stata, though, the quadratic term is not significant, which is interesting. So I don't know why they're converging onto different results, but I can tell you the point estimate is pretty much the same, but the standard error is very different. So maybe some additional bootstrap replications would be in order to try and help see if that solves some of the differences across packages. In our output, this is what you get. You get a point estimate and a confidence interval. So you can use that to decide whether or not the coefficients overlap 0. So it looks like R agrees that square footage squared should not be significant with respect to its variability. So, questions so far? So if all you wanted to do was solve the problem that you have outliers and you want to predict a DV without having to kick out outliers, this solves the problem. The next options are used to address different kinds of questions. So you can customize these analyses to predict particular percentiles, such as the 25th and the 75th. So I picked those somewhat arbitrarily, but the 25th percentile would be a relatively cheap house, so inexpensive relative to the rest of the sample, whereas the 75th percentile would be an expensive house. And so by asking for models that predict those two percentiles specifically, another way of thinking about that is saying, amongst cheap houses, what's the most important factor? That's the 25th. Amongst expensive houses, what are the important factors? So this is kind of like thinking of it conceptually as a slope by outcome variable level interaction, because these sorts of questions are asking, is there a different relationship between a predictor and an outcome at different points of the outcome? So this is not the same thing as, say, a quadratic relationship, because that's asking if there's a different relationship at different points of the predictor. So we can square a predictor to find out if its slope changes as the predictor goes up or down. This is asking if there's a different relationship between the predictor and outcome at different points of the outcome. So amongst cheap houses, what matters? Amongst students who do relatively poorly, amongst people who are slow responders. Like you can think about sort of the lower end of the distribution as a focus in and of itself, or the higher end. So it turns out to be super easy to do this. Here's the difference in SAS. You just list both quantiles that you want, and then you get 2 sets of regression results. In Stata, you do the same thing. In the quantile option, you can list both of them. I have added some additional code that I found that's useful. So I have added a multivariate walled test of each model. So since I'm asking for 2 models, it's going to spit it out for each one. And I found this cool thing, Qinteract, which is going to provide me with a test of whether the slopes significantly differ between the models. So does the model work differently if it's predicting the 25th percentile than the 75th percentile, for instance? So this test statement that I have highlighted lumps them all together. This is how you would do it for each individual slope. Okay, with me so far? Now, Stata users, where's my Stata users? Kendall, Sam, Nikki, anyone else? Min? Okay, so you're going to like this. People who made Stata, I swear, they made it for data analysts. Like, that is how it's written. It's like, oh, what would you want to know? Oh, let me build that into Stata for you. So Stata has this SQReg thing, which allows you to test whatever quantiles you want. And then I figured out how to ask it for the F-tests for each model. So in Stata, these little bracket things are specifying which model the term is referring to. So this is specifically the slope for differentiating old and new construction in the model predicting the 25th percentile, whereas this is the same slope in the model predicting the 75th percentile. And I built this giant thing right here to test whether each of the slopes differ across the 2 models. So that's going to give me a joint hypothesis test of whether the overall 2 models differ from each other. I would have to do a separate test for each one, but the people who made this in Stata expected us to want to know this, and so they actually made a routine that does it directly. So in addition to SQReg, I have a demonstration here of IQReg, which directly gives you the differences between slopes across the 2 models. So you get the hypothesis test built in. And in R, none of that coolness, but I can ask for multiple quantiles at the same time. So then SAS output gives me 2 different solutions. So the 25th percentile for the reference house is $101,000. The 75th percentile for the reference house is $145,000. And you can look and see what the rest of the effects are here. So it looks like, yep, square footage. The linear effect of square footage is the only thing that matters significantly according to SAS in predicting the 25th percentile. Bigger houses have sell for more money. And it looks like down here, the same thing, bigger houses sell for more money. And then here are the test results trying to look at whether or not the model works. This is whether the model is significant at the 25th percentile, at the 75th percentile. These are the differences across the slopes on the whole, so it looks like overall the model works about the same. And this is the difference for just the one slope as an example. In the Stata output, it's organized the same way. So it first gives you the 25th percentile and the 75th from SQReg. And then here's the output from IQReg, where these are slope differences. So it's directly telling you how much different each of the slopes is between the model predicting the 25th percentile and the 75th percentile, which I found very useful. And the results agree across those 2 programs at least that basically all of these are non-significant, indicating they work pretty much the same across the 2 percentiles. And then here's the results from R for each of the 2 solutions here. Okay. Pausing for a drink here. Questions so far? one more really cool thing that I found in SAS and not in the other packages. So I think we can agree that 25th percentile and 75th percentile are somewhat arbitrary, right? For low versus high. I just picked those because those are commonly used to describe interquartile range as a measure of variability or dispersion. I can ask for all of them in SAS, and I did. So this takes a few minutes to run, but I think it's actually really cool. So I switched out these two options here. Quantile equals process, which means all of them. And plot equals quant plot, meaning, can I have some pictures? So what is not included in this handout is the 87,000 pages of output that this generated, because it gives you a solution for every single possible quantile. But it summarizes how the slopes change across quantiles in these handy-dandy pictures. So this one's for the intercept. You would expect that the intercept is higher as you move up the distribution, so there's no surprises there. This one is for the effect of new construction. So after controlling for house size, number of bedrooms, number of bathrooms, it looks like the effect of new construction is positive, but borderline significant. So this slope is largely the same across quantiles. Some of the others, though, change in interesting ways. So the number of bedrooms, 3 versus 2, that is actually related to, has a positive slope more so as you move up the quantile, which is interesting, because you would expect that 2 bedrooms would make the house price lower rather than 3, but that's probably a proxy for condominiums or some other thing that would differentiate smaller units that cost a lot of money. Then we get things like this. So this is the quadratic term that seemed to be falling in and out of significance as we went across quantiles. So what this plot is showing here in the bottom right is that there is a negative slope for the quadratic term in the cheap houses. It switches over to positive and becomes more positive and actually significant as you cross from about 0.5 to 0.7-ish. So it looks like that acceleration that we found in that square footage matters more as you move up square footage only happens in the mid-range houses. It does not appear to be significant in the lower ones or the upper ones. This has a lot more noise. So this can give you like a much broader picture of how your slopes work in predicting any level of your outcome. And then here's some words, as promised. So anyone who tells you that you need to do outlier analysis, this is what you say. No, I don't. I can do quantile regression, thank you. If you have outliers because people lied to you or gave you implausible values, that is a different problem than just having extreme values that are legit. I think extreme values that are legit get kept. All right. Any questions before we call this one done?
Lisa, a quick question.
Yes, please.
When reporting these results, do you typically see the differences reported or kind of everything, like 25th percentile, 75th percentile, and differences?
I would say that I have not seen a lot of these in practice, but that the answer would depend on how you phrased your research questions. So like if you have questions like what predicts amongst low performers and what predicts amongst high performers, that lends itself to just describing what happened in each model. If you had a question like, my intervention was more effective on low performers than high performers, then that lends itself to a test of a slope difference across the models for each separate quantile.
Okay, that makes sense.
Yeah, so it's a depends. It's an it depends kind of answer. I did add a reading that has, I think it's like something like Quantile Regression in Education Research or something is the title, which seems like that'd be relevant. So that's on your list as one example. I haven't seen this used very much, to be honest, and I think it's just a lack of awareness because it seems like it's really straightforward and applicable to a lot of situations. However, these models have the same limitations as every single thing that we've talked about this semester, which is that we are talking about independent samples for all of the models that we've hit thus far. And that changes now. Dun, dun, dun. So, question?
Before we move on,
Yeah.
for the homework,
For the homework.
one other question that came to mind.
Okay.
Why did we fit a negative binomial
Not that one.
distribution instead of just, okay, let me rephrase. Would it have made more sense to do like a zero inflated model? Or zero inflated negative binomial distribution for this?
Okay, so the question was...
Or hurdle submodel.
Yeah, our hurdle. In this case, I think the reason you're asking that is that you're confusing the idea of food school as a predictor versus an outcome.
Oh, okay.
So yeah, I wanted to do something that was more complex with the linear model aspect, but the food school is a hurdle conceptually, but it's on the predictor side.
Okay.
We're predicting number of new foods tried.
Okay.
And I generated these data such that they were not zero inflated. They're just number of foods.
Okay.
But if it was the case where there were certain children who never were going to try anything new, such as mine, and there were a lot of those children in the data set, then we would potentially need to do a zero inflated option.
Okay. So if food school was the outcome instead of a predictor, then we probably would have had to revisit that.
Yes.
Okay.
Yeah, like if I was predicting compliance and like number of sessions attended, and some kids just never went, and that was an informative outcome, then yes.
Okay.
Yep. Generally speaking, I would say that you want to try to fit the linear predictor and then look at whether you need the extra variance stretchy factor and then see if you need zero inflation also. Because zero inflation and the stretchy factor put into the negative binomial to some extent are trying to explain the same phenomenon.
Mm-hmm.
And so you may not need both.
Okay.
And if you don't need both, then you can look at AIC and BIC to see which one is better, and you can do likelihood ratio tests against reduced models to try and decide that too. But yep. Okay, other questions? All right, then I am going to